The Internet is growing at a phenomenal rate. Engineers grapple with how to best architect and operate it when it is dynamically changing as rapidly as their ability to monitor it. The robustness and reliability of the Internet is highly dependent on efficient, stable connectivity and routing among the networks comprising the global infrastructure. Evaluating the health of this global infrastructure requires the development of new technologies for collecting macro-level data across multiple Internet service providers. CAIDA is adapting successful related techniques from other research fields. In computerized X-ray tomography, for example, a three-dimensional object is examined through a series of thin cuts between source and destination points. Multiple two-dimensional images can then be used to reconstruct the three-dimensional object. With the goal of developing tomographic-like techniques for the Internet, CAIDA began work in mid-1998 to develop and deploy tools to collect, analyze, and visualize data on connectivity and performance of traffic. SKITTER was developed to dynamically discover and depict global Internet topology and to measure the performance of specific paths through the Internet. SKITTER got its name from skipping flat stones across water, also called skitters. SKITTER is a traceroute-like tool that implements TTL, or time to live, at each hop. SKITTER's architecture is based on parallel ICMP probes, 52-byte packets, kernel time stamping, and SSH or Kerberos. By skittering across networks, the SKITTER tool attempts to discover clues about connectivity and routing among networks and path-specific performance. Traceroute-like tools illustrate adjacencies among networks as depicted through individual paths. SKITTER data helps analyze macroscopic traffic patterns with insights into effects of outages on surrounding ISPs, effects of topology changes on Internet performance, unintended consequences of new routing policies, potential areas for improving an individual network's ability to respond to congestion and topology changes, and infrastructure vulnerabilities created by dependencies on particularly critical paths. A modified kernel adds a timestamp to round-trip data collected by SKITTER. This provides a means of depicting path-specific variations in performance across Internet infrastructures. Asymmetric routing, however, limits the accuracy of these performance measurements. Configuration differences in Layer 2 infrastructures further limits visibility. SKPIng is a related, ping-like SKITTER module measuring round-trip times to specific destinations. SKPIng runs at varying resolutions from 2 to 30 packets per second, depending on network loads. This is used in performance evaluation and analyzing the frequency of route changes. Continuing efforts at CAIDA include increasing the number of monitors, analyzing correlations of SKITTER data with workload data and routing data, enhancing data mining and visualization techniques, and improving aggregation techniques.